In the previous video, we discussed first 6 questions in this paper. So today we'll move on to question number 7. So in question number 7, it says, a student uses this method to investigate the reaction between sodium hydroxide solution and dilute nitric acid. So we'll just mark what they are saying, right? First they are saying that pour 20 cubic centimeter of dilute nitric acid into a 100 cubic centimeter glass beaker. Okay, we have a glass beaker. So in this glass beaker, we have 20 cubic centimeters of nitric acid. So we have 20 cubic centimeters of dilute nitric acid. The formula of nitric acid is HNO3. Measure the temperature of the acid. Add 5 cubic centimeters of sodium hydroxide solution and stir the mixture. Okay, so now what you are going to do is you are going to add 5 cubic centimeters of sodium hydroxide. So best way we can add volumes by measuring. When you add liquid by measuring its volume, is best way is using a burette. So we are adding 5 cubic centimeters of sodium hydroxide solution from the top. So sodium hydroxide is a base or alkali. HNO3 is acid, so it's simply an acid-base reaction. Record the highest temperature reached. The student repeat the step 3 and 4 until total of 40 cubic centimeters sodium hydroxide solution has been added. So what this student is going to do is, he's going to measure the temperature of this solution by adding 5 plus 5 cubic centimeters each time. He had 5 cubic centimeters of sodium hydroxide, measure the temperature. Again at 5 cubic centimeters of sodium hydroxide, measure the temperature. So he keeps on adding this sodium hydroxide solution until you completely add 40 cubic centimeters of sodium hydroxide. So we had 20 cubic centimeters of solution in the bottom of acid. Now we had 40. So altogether I have 60 cubic centimeters of aqueous solution. How come? Because I already had 20 cubic centimeter. I added 40 cubic centimeter into it. So 20 plus 40 is equal to 60 cubic centimeter. So that's the story it says, right? So then they are saying that, right, let's see what we have next. The graph shows the students' results. Now we know that we have 20 cubic centimeters of nitric acid. When you add 5 cubic centimeters of sodium hydroxide, what will happen? Our nitric acid HNO3 will react with sodium hydroxide, is an acid-base reaction, gives you sodium nitrate, a salt, plus water. So we know that when a reaction takes place, heat is, if this is exothermic reaction, they will give out heat. When they give out heat, what will happen? That heat will rise in temperature. So what will happen? Temperature increases. Yes, temperatures increase. You can see temperatures keep on rising. When you add another 5, okay, more sodium hydroxide react with HNO3, more heat is produced, temperatures increasing. Temperature keeps on increasing and came to the maximum point. After maximum point, you can see the temperature is decreasing. That means after this maximum point, there is no more reaction. That's why temperature is decreasing, because no more reaction to produce heat. So this is the end of the reaction. So that means end of the reaction, we call it end point. That means we had only 20 cubic centimeters of HNO3. Can you remember? We had a limited amount of HNO3. That means since we are adding a lot of sodium hydroxide, at the end point, all HNO3 got reacted completely. Right, since all the HNO3 got reacted completely, that's why the temperature decreases. So at that highest temperature point is the where all the HNO3 get reacted. So that's the thing. Okay, so we have Determine the volume of sodium hydroxide solution at the point where the line crosses. They don't ask big things. They're asking when the line crosses, what is the volume of sodium hydroxide added. So that means this point is slightly from this point after one box. So I'll just go so you can do it more properly, because remember, when you're dealing with these points, you have to be so precise, right? So I'll try to be precise as much as possible. So I can see after 20 in one box and a half of the box, no? So I know that one box is 1, so 20, 21 is here, 22, 23, 24, 25. So it's between 21 and 22. So therefore I assume this volume is 21.5 cubic centimeters. So when I add 21.5 cubic centimeters, I will get the highest temperature this line crosses. So if you check the marking scheme, they have given the range. They are not giving big range, right? They are giving very short range. In the marking scheme, they have given 21.4 to 21.8. So our volume is in between 21.4 and 21.8. So therefore no need to worry, right? Then the graph shows students' results. Determine the maximum temperature change reached during this investigation. Now they want to find the maximum temperature. Maximum temperature change. Okay, anyway, we started from temperature change. No, yes, here is marked in. So I just thought like temperature change means we have to find the temperature difference, no? But here they are giving the temperature change. So we have to find the maximum temperature range. I can see that in this line, this is the line. I can see it here. For that line, slightly above, we have our line. Slightly above that line. Let's see what are, yes. So 15, is it 16, 17, 18? No. It's 2 by 2. So this is 16. This is 17. This is 18. This is 19. This is 20. Okay. So it's slightly above 16. Since slightly above 16, I'll say it's like, yeah, it's little bit below 16.5, because if there are two boxes, the middle line is 16.5. This is 16.5, below 16.5. So I'll take like slightly above. So I'll take this one as 16.2 degrees Celsius. So if you check the marking scheme, they have given a very narrow part, 16.1 to 16.3. So if we have within this range, then you get marks, right? So these questions are very easy because they just expect you to find the reading, take the reading from these graphs, and what you have to do is you have to be careful when you take the reading, right? A student makes this statement about the shape of the graph. The first line on the graph shows that the temperature rises at a steady rate as more nitric acid is added and 40 cubic as more nitric acid is added. I saw something fishy about it, because we didn't add nitric acid. We had what? We had sodium hydroxide here. We didn't add nitric acid, so that statement is wrong. Nitric acid added, temperature rises shows that as more nitric acid is added, and at 40 cubic centimeters the nitric acid has been neutralized. No, at 40 cubic centimeters nitric acid do not neutralize. Nitric acid get neutralized here. All the nitric acid get reacted complete. That's what we call a neutralization point. It get neutralized this 21.5 cubic centimeter, not at 40. That's wrong. The student statement includes some mistake and it is incomplete. Give two mistakes in your student statement. So we know the two mistakes. Sodium hydroxide should be added. Not nitric acid. That's the first point. Second thing, neutralization neutralization of nitric acid takes place at what was the volume we found the endpoint? We found that point. Let's see, 21.5 at 21.5 cubic centimeter of sodium hydroxide volume, not 40 cubic centimeters. Right, those are the 2 points we have for answer for this question. Add another sentence to complete the student's statement. So he didn't talk about this temperature decrease, no? So because he talk about only at 40 temperature go for the highest, but it's not 40, something else. He never talk about temperature, why this temperature decreases. So you know why temperature decreases? Because after this point reaction is complete, and then what will happen? There's no more reaction to produce heat. So therefore, since the room temperature is lower, temperature will also drops down. It's just like when you have a cup, when you make a cup of tea, after it is done, when you keep it on top of the table, it cools down because heat goes out to this environment. As a result of that, it cools down. Same thing what will happen. So therefore, we can say that temperature decreases after the neutralization point, or you can call that endpoint. After the neutralization point, which is I forgot the neutralization point, 8. Let's go back and see, 21.5 cubic centimeters, which is 21.5 cubic centimeters. 21.5 cubic centimeters. So 1 mark question, that's enough. That's enough for that question. Okay. Then they say that the student repeats the investigation as the student start with 25 cubic dilute nitric acid. Now it's a different scenario, right? So I'll just write it here. So we have HNO3 here at the bottom. How much? 25 cubic centimeters of nitric acid. Our room temperature is 19 degrees Celsius. The student finds that 25 cubic centimeters of sodium hydroxide solution is needed for complete neutralization. To neutralize this one, we need to add 25 cubic centimeters of sodium hydroxide. The student calculated the heat energy released, which is Q, equals 3780 joules. Specific heat capacity of the solution is given, density of the solution is also given. Calculate the maximum temperature reached. Now they are asking maximum temperature reached. You know this equation, Q equals MC delta T. Q means heat energy. Do you have heat energy with you? Yes, I do. 3780 joules. Okay. Then do we have the mass of the solution? Yes, mass of the solution I can find here. Can you see this density? This density simply say that if you take 1 cubic centimeter, what is 1 cubic centimeter? 1 cubic centimeter means it's a cube which is 1 centimeter length, 1 centimeter breadth, 1 centimeter height. That's 1 cubic centimeter. They say weight of this 1 cubic centimeter is 1 gram. That's what it says. Mass of 1 cubic centimeter solution is 1 gram. So how much volume we have? We had HNO3 25. To this 25, we add 25 cubic centimeters sodium hydroxide together. So therefore, total volume of this solution is 50 cubic centimeter. 25 plus 25 is 50. So therefore, if 1 cubic centimeter is 1 grams, 2 cubic centimeter is 2 grams, 10 cubic centimeter is 10 grams. So 50 cubic centimeter is 50 grams. So mass is of the total solution is 50 grams. This is one of the major points. Students make mistake because they see only 25 cubic centimeters of HNO3. They put it as 25, known as 25. When you mix another volume, because after they mix only the reaction take place, you have to take the total volume after they mix, and that's 50 grams. Specific heat capacity is given C, which is 4.2. Temperature change is the question. They are not asking temperature change, but if you find temperature change, we'll be able to do the rest. Okay, let's put the values. So it says 3780 equals 50 times 4.2 times delta T. Let's find delta T. So delta T equals, I have take 50 and 4.2 to other side. So 50 and 4.2 goes to the other side is 3780. 50 times 4.2 comes as a division. 50 times 4.2. So when you do this calculation, you will get, okay, so you get 37,000. Yes, you get the answer is 18. 18 is the temperature change. So 18 degrees Celsius. But that's wrong. That's not the answer because they're asking maximum temperature. So delta T means, what is delta T? It's the final temperature minus initial temperature. Temperature change is like that. Temperature change is how much temperature change. For an example, now let's take in the morning when you wake up, the temperature in your room is like 15 degrees. By the daytime, when it goes to like 12 o'clock in the noon, it becomes 20. So they're asking what is the temperature change? You will wake up at 15 degrees and by the noon it became 20. So you have temperature change of 5 degrees. So that's a change. It doesn't tell you what is the temperature when you wake up, and it doesn't tell you what is the temperature during the daytime. So same thing here, delta T is 18. What's the question they're asking? Final temperature. That's the question they're asking. But initial temperature they have given, can you remember? They start the temperature at 90. Some value minus 19 is 18. So how to find this value? That value means then 18 is there. You take 19 to other side. When a subtraction goes to other side, it will become addition. So 18 plus 19, our answer is 37 degrees Celsius. That's the final temperature, maximum temperature reached. Okay, now we have the maximum temperature. The amount of dilute nitric acid used in the investigation was 0.079 moles. Calculate the delta H in kilojoules per mole for the neutralization reaction. Include a sign in your answer. Now they ask you to find the enthalpy change. To find the enthalpy change, there is an equation. Equation is heat change, which is Q, or heat energy, divided by number of moles of the reactants. Number of moles of the reactor. Do we have the enthalpy change? No, that's the one we have to find. Heat change. Heat change is 3780 joules. Go back and see. It was joules, not kilojoules. Why I'm talking about it? Can you see the unit they are expecting here? Kilojoules, right? Then divide by number of moles is given. Nice, so easy. 0.079 moles. So first I will change this joules into kilojoules. How to change joules into kilojoules? You have to divide simply by 1000. So what you have to do is 3780 divided by 1000 will give the answer in kilojoules. When you do it, so you can write the enthalpy change. 3780 divided by 1000 is 3.780. Now it is in kilojoules. Divided by 0.079 moles. When you do this part, you get the answer as 47.8 kilojoules per mole, and that is wrong. Why? Because the reason is there's a sign. When you talk about enthalpy change, you have to talk about whether they are giving out heat or whether they are absorbing heat. Now in this reaction, what happened to our thermometer? Thermometer temperature went up, right? So increases. Why thermometer temperature increases? That means our reaction, let's assume reaction take place in this box, gave us heat. They gave us heat. Because our reaction gave us heat, that's why the temperature increases. If any reaction giving out heat, giving out means going out. When you see going out, in your door, you have see going out. What is the word to going out? Exit. They are going out. They are exiting. Exiting heat. What heat? Heat, thermal. Heat means thermal. Exit thermo. So that means exothermic. That is exothermic reaction. So this is exothermic reaction. How I'm going to tell that it is an exothermic reaction? How I'm going to tell it? To tell something exothermic, there's a way. How to tell exothermic? This is the reason. So let's assume there's a reaction. So they have reactants. They have certain amount of energy. Let's assume their energy is 500 joules. Then they're giving out. So that's like you have $500 in your hand. You give out $100. Let's assume that means they are giving out 100 joules. When you give out 100 joules from 500, so you had $500, you gave 100 out. How much you are left with? 400 joules. That means when you give out energy, the products will have less energy than the reactor. Right, so products will have less energy than the reactor. So how to find the change? So always remember, when you are finding a change, delta, I say delta change always final minus initial. Final is the products is 400. So final is the product is 400. Initial is a reactor minus 500. So that means you are subtracting a larger value from a small value. So small value minus big value, your answer will be a -1. So if you want to tell it's an exothermic reaction, it's minus 47.8. Remember, it's minus 47.8. So the simple idea here, if it is exothermic, you have to tell it saying that it is minus. If it is endothermic, you have to put the enthalpy change as plus. So since this is an exothermic reaction, our answer is minus 47.8 kilojoules per mole. Then only we get full mark for this question. That's how we get the answer. Right. This question is about ionic compounds. So we finished that calculation. Now let's move on to this one. The table shows the formula of some ions. It also shows the formula of the same compound containing these ions. Complete the table by giving the missing information. This is so easy. So here I have write the combination of lithium plus ion and sulfate ion. There are two ways. What you are going to do is you write the first one, lithium. What is its charge? +1. +1 means its valence is 1. Then you write sulfate ion. It is -2. Here charge is given now. -2. So its valence is 2. No need minus or plus. So when you write it, what you do simply do is you just exchange their valences. So lithium get that 2, Li2, sulfate get that 1, Li2, SO4. So when there's 1, we don't put it. So this is Li2SO4. There's another concept here. I'll just only teach for this one. Lithium is +1, no? Sulfate is -2. So sulfate is -2. If there's -2 to neutralize it, to make it 0, 1 plus is not enough. You need 2 plus 1s. +1 +1 +2 +2. This side is +2. This side is -2. +2 -2 is 0. So that's why 2 lithium plus ion is required to neutralize this 1 sulfate time. That's the reason. But for now, we'll use that exchanging of valencies. Here we have nitrate with magnesium 2 plus ion. Magnesium charge is +2, so therefore valency is 2. Nitrate charge is -1, so valency is 1. Let's exchange them. So magnesium get 1, nitrate get 2. So when I put in this one, now we have problem. When I put 2, they have doubt. Students will have doubt. Is this 2 belongs to only this oxygen, or is it belongs to this whole thing, nitrogen, or is it belongs to this magnesium also? Is it doubt? No. To avoid this doubt, we are going to say that which ions belongs to this 2. So therefore we put a bracket. We know that whole NO3 group belongs to this 2. So therefore is MgNO3 twice. So we can write simply here is MgNO3 twice. Right. Let's go for aluminium phosphate. Aluminium is here. Usually we write the metal ion first. Valence is 3. Phosphate is here. PO4. Valence is also 3. Exchange them, you get Al3 PO4 3. When you have the same number, Al3 PO3, you can take the simplest ratio. 3 aluminium, 3 phosphate is same as, you can put the simplest ratio, 1 aluminium and 1 phosphate. 3:3 is same as 1:1. So when you get the same number in both cases, you can put it as the same simplest ratio. This is simply AlPO4. Because same reason, when you have -3, PO4, 3 minus, no? To neutralize it, 1 plus 3 is enough. Al3 plus can neutralize PO4, 3 minus. That's the idea here. Right, we just fill the table. Explain why magnesium oxide has a higher melting point than sodium chloride. Refer to the structure and bonding in your answer. Right. For that, I want to tell you something before that. These are the things you have to know, right? If you take magnesium oxide, is made out of, we just learned that in the previous table, is made out of magnesium 2 plus. And since there's only one oxygen, we know that oxygen is also 2 minus. So because oxygen is group 6 element, they need only, because oxygen is in group 6, no? Group 6 means to become group 8 element, they need 2 electrons. Because they are just lack of 2 electrons. So therefore they are taking 2 more electrons to go for group 8. That's why they form O2 minus ion. So they are group 6, so it's O2 minus. And if you take sodium chloride, it's made out of, sodium is group 1 metal. So it's made out of sodium plus 1 ion. Chlorine is group 7 metal. It needs only 1 more electron to go to group 8. So it has minus 1. So we have plus 2 minus 2 and plus 1 minus 1. They are asking which one. Refer the structure and bonding. Explain why magnesium oxide has a higher melting point than sodium chloride. So this is the point you have to remember. These are ionic compounds. So in an ionic compounds, remember more charge means, so that means if you have plus 2 and minus 2. Plus 2 and minus 2, there will be attraction between them. Plus and minus 1, there will be attraction between them. But plus 1 minus 1 will have less attraction than plus 2 and minus 2, because more charge means greater attractions. because ionic bond means attraction between ions. So therefore, greater the charge, greater the attraction. So that's the part we are going to write it here. So we have to write 5 points, right? Okay. This is how we write the 5 points. So first, when you are going to, what they are saying, explain. When they are saying explain, we can write similarities as well as differences. Let's write. Okay, first point I'm going to write both. We are going to first say that both are ionic compound. Both sodium chloride and magnesium oxide are giant ionic lattices. So we know that if you take ionic compounds, not only one sodium plus ion with one chloride ion, no. In ionic lattices, always when you have one sodium plus ion, there will be more chloride ion attracted to that. You know that is 6 chloride ions. And when there's one chloride ion, more sodium plus ion will be attracted to that. So that's how it goes. So they don't stay 1 or 2 ions together. They stay as giant lattices, large number of ions together. So that's what is called giant ionic lattices. Right. Second point, we can write, and they are attraction between the oppositely charged ion. So we can say that they have electrostatic attraction between negative and positive charge ions. So we can say between oppositely charged ions. Okay, that's the second point. Now they have attractions. Now we have to say that magnesium oxide has strong attraction. Why? Because it has greater charge. So we can say that magnesium oxide has ions which have greater charge than sodium chloride. So you can show it if you want. Magnesium 2 plus attracting O2 minus, sodium plus attracting Cl minus. Okay. So therefore we can say that stronger attraction between magnesium oxide due to greater charge density. So therefore this attraction mainly depends on, we call them based on charge density. Charge density means we assume them as spherical ions, no? So when you have more charge in a given volume, you will say that it has greater charge density. So this like sphere of magnesium 2 plus has greater charge, 2 plus ion. But here this sphere of sodium plus ion has only 1 plus charge. So 2 plus in one sphere, in the same size of sphere, in an ion, so therefore it will have greater density of charge. That's what we say. So therefore finally we can say that therefore more energy is required to break magnesium oxide lattice. Since magnesium oxide lattice require more energy to break, that's why it has higher melting point than sodium chloride. Okay. We wrote 5 points explaining the structure and about their ion charges and the attraction between them, and then we told that they need more energy to separate magnesium and oxide ion from the magnesium oxide lattice. Right. Now we have a question. This question is about propene and propane. Okay, propene and propane. Complete the table by giving the missing information about propene. Propene means it's an alkene. So displayed formula of propene. We know that prop means 3. 8 meth prop. You put 3 carbon. Displayed formula. You have to show all the bonds and all the atoms. Propene are between 2 carbon atoms. There will be double bond. And all the others are hydrogen. So here we have hydrogen. One carbon atom should have 4 bonds. 1, 2, 3, 4. This one you can see 3 bonds. So we have the 4th bond. And here we have 3 more bonds. Right. Molecular formula of propene. Molecular formula of propene is C3H6. Yes, we can see 1, 2, 3 carbon. 1, 2, 3, 4, 5, 6. 6 hydrogen. Empirical formula of propene ratio 3:6. Simplest ratio is 3:6, means if you divide both sides by 3 divided by 3 is 1, 6 divided by 3 is 2. So the simplest ratio here is C1H2. So here C1H2, that means CH2. Relative formula mass of propene, molar mass of propene. So it is C3H6, no? C3H6. Carbon is 12. So there are 3 carbon atoms. So it's simply 12 times 3 is 36. Plus hydrogen is 1, no? There are 6 of them. So it's 1 times 6. So we have 36 plus 6. It is 42. So that's the relative formula mass of propene. Draw dot cross diagram for propane. Include only outer shell electron. Okay. Now I'm going to draw dot cross diagram for propane. First I'll draw the displayed formula of propane, right? That makes it easier for me. We have 1, 2, 3. Okay, there are only single bonds. Carbon need 4 bonds, so this will need 3 more hydrogen atoms. This will need 2 bonds are there. This will need 2 more hydrogen atoms. This one need 3 more hydrogen atoms. Because most of the students confuse this one, I'll just draw this one with using different colors, right? So I'll draw the first carbon atom here. Okay, first carbon atom. Carbon has how many electrons? 4. So I just draw those 4 electrons using 4 crosses, right? Right. Next to this carbon atom, you can see that there's another carbon atom. Okay, so there's another carbon atom. So since there's another carbon atom next to this one, we can say, okay, next to this carbon atom there's another one. I'll draw that carbon atom is like this. Okay. Now if this carbon atom is a cross, I have to use this carbon atom dots. I can't say all the carbon atom will have crosses. No. If one carbon atom is cross, otherwise I have to use the other carbon atom in dots. So these are dots, 4 dots I put it. Next to that carbon atom there's another one. If this is a dot, next carbon atom is a cross. This is crosses. Right. Then what I'm going to do is, now I have to draw the hydrogen. So this first carbon atom hydrogen, I'll draw it in this purple color. So if this carbon atom has cross electron, hydrogen electron should be dot. Okay, 4 hydrogen, 3 hydrogen came. So this is the other hydrogen, this is the other one. So I can mark the area of this carbon atom using this. So it has 4 covalent bonds. Right. For this carbon atom, I'll take those hydrogen atoms in brown color. if this carbon atom is dots and the hydrogen atom, you'll use crosses. This is this hydrogen atom. This hydrogen atom comes. Okay, use a cross. So area of this carbon atom, I can use a circle to show that the electrons belong to this carbon atom. Okay, this carbon atom has crosses now. So the hydrogen atom joined with that carbon atom will be dots. Here. So the summary here is, when you showing a covalent bond using dot cross diagram, if one is a dot, other one is a cross. So if one is a cross, other one is a dot. So we have this structure. So if I am going to draw this structure, so this is how it happens. Using a single color, you can't use all these colors. So this is a simple thing. So what I'm going to do is, I'm going to draw the hydrogen. So since this carbon is crosses, hydrogen will be dots. And the next carbon atom will be a dot. And the next carbon atom will be crosses. So hydrogen joining with middle carbon atom will be crosses. Hydrogen joining this corner carbon atom will be dots. But can you see, you just place the atoms how they are in the displayed formula, and whenever you see a line, you replace that line using a dot and a cross, isn't it? So these are not hard stuff. That's what you are doing. If you know how to draw the displayed formula, that's it. You know how to draw the dot cross diagram. So simply where you see a line, you just simply place dot and a cross. Who belongs to that dot and a cross and who belongs to the crosses, which atom belongs to the dots, you don't need to think during the exam. Only thing is, you should be able to draw accurate displayed formula. Then drawing dot cross diagrams are so easy. That's the summary here we have to learn. Right, so we got the... Okay, now let's go for this one. Propene and propane reacts with bromine. Okay, both react with bromine, which shows the correct number of products for these reactions. Okay, we are having a propene 1 bromine, propane and bromine is only 1. Okay, give the reaction condition need for this propane and bromine react together. Okay, for this one, I'll use this place. Okay. Right, so this one we have talked about propene and propane, how they react with bromine. Let's take propene. So this is propene, right? When propene reacts with bromine, this is what happens. The bromine atom goes, it's a bromine molecule, and they will break the bond between them. So they will break this bond. So they will break this bond. Here bond they will break. Then this double bond also breaks. So slowly this carbon attached to one bromine, other carbon attached to the next bromine. So that's what simply happens. So when they react, what we are going to get here is hydrogen, carbon, hydrogen, and carbon, hydrogen, CH3. Now the two bromine atoms go there and attach to it. I don't see any other way of they react. So for propane, I will see only one product is forming. Let's go to propane. One carbon. So in propane, it's a substitution reaction. Substitution means bromine simply replace one of the hydrogen in this molecule. So therefore, when I add bromine, simply what happens, the existing hydrogen, let's take this hydrogen going to replace, it goes with this bromine forming HBr. And this bromine will come there and replacing this hydrogen. So it's become bromine. But what if this bromine goes and replace this hydrogen instead of the corner one? Yeah, you can have two options. What are the options we can have? Let's see. The option number one I can have here is bromine can replace hydrogen in the corner carbon. That's the one option. Second option I can have here is bromine can replace hydrogen in the middle carbon. That means hydrogen in the middle carbon get replaced by bromine. That's what will happen there. That means I can get two products from this propane. So propane gives me two products, but propene gives me only one product. Okay, so therefore they are asking propene and bromine. Propene and bromine, there will be only one product. Propane and bromine gives you two product. Alright, so the answer for my question is, this question is, answer is B, because it's 1 and 2. And the next one, they're asking, give the reaction condition need for propane and bromine to react together. Alright, we should know the reaction condition for this reaction. The condition for this one is ultraviolet light. We need UV light or UV radiation. With UV radiation only, this reaction takes place. So therefore, answer for this one is ultraviolet radiation. Okay. Then we'll go for next one. A compound formed in the reaction between bromine, water and alkene has this percentage composition by mass. A compound from the reaction between bromine, water and alkene. Okay. Calculate the empirical formula of this compound. Okay. So when you find the empirical formula, this is how we do it. First you write the elements you have. Carbon, hydrogen, oxygen, bromine. It's better if you know their molar weight, right? Look at the period table, you will find carbon is 12, hydrogen molar atomic weight is 1, oxygen is 16, bromine is 18. You take their percentage. So carbon has 25.9%, hydrogen has 5%, oxygen has 11.5%, bromine has 57.6%. So this percentage means what? If we have 100 grams, if 100 grams are there, number of grams of carbon is 25.9 grams. Mass of hydrogen is 5 grams. Mass of oxygen is 11.5 grams. Mass of bromine is 57.6 grams. Same as the percentage. Percentage means out of 100, how much? Okay. Now we'll find the number of moles. How to find the number of moles? Number of moles is mass divided by molar mass. So mass of carbon is 25.9. Molar mass of carbon we have it is 12. Mass of hydrogen is 5.0. Molar mass of hydrogen is 1. Mass of oxygen is 11.5 grams. Molar mass of oxygen is 16. Mass of bromine is 57.6. Molar mass of bromine is 80. When you divide with, we will get the answers as 2.16, 5.0, 0.72, 0.72. Now you have to take the simplest ratio. How to take the simplest ratio between these moles? So you take the simplest ratio, you take the smallest value. What is the smallest value? 0.72. You divide everything by 0.72. 21.6 divided by 0.72. 5 divided by 0.72. 0.72 also divided by 0.72. 0.72 divided by 0.72. Then you get the answers. 21.6 divided by 0.72 is 3. 5 divided by 0.72 is 6.94. It's more than 6.9. It's very close. So that means we can say it's almost 7. 0.72 divided by 0.72 is 1. 0.272 divided by 0.72 is 1. So my answer is 3 is to 7 is to 1 is to 1, which means C3H7O1 Br1. C3H7O Br. That's our answer. Right, let's go for next one. Ethene and propene contains the same functional group. So ethene and propene, yes, both are alkenes. State what is meant by the term functional group. Alright. Before that, how this molecule CH3Cl becomes halogenoalkane? Because of the chlorine atom. So it can be an atom. How this molecule become an alkene? CH3. How propene become alkene? It's a bond. So you can say that bond, or you can call it part of a molecule. Bond or part of a molecule. How this methanol become an alcohol? Because of this OH group. Or you can have group of atoms. So simply what you have to know here is atom, bond or part of molecule or group of atoms which decides the chemical properties of a molecule. That's what we call functional group. Atom, bond, part of molecule or group of atom which decide the chemical properties of a molecule. We call it functional group. Draw an isomer of propene that does not have the same functional group. Isomer of propene does not have the same functional group. So we have propene, right? So I'll draw propene here. 1, 2, 3. So when I come for a propene, so carbon should have 4 double bonds. Now they say that draw isomer of propene but cannot have this double bond. We are in a big trouble. This is a common question they always ask. Remember, now the thing is, we know alkanes and alkenes. So if we can't draw propene, next one we can draw is propane, no? We'll try to draw propane. But when I draw propane has C3H6, only 6 hydrogen. Okay, I put 5 hydrogen. What about these 2 bonds? I don't have enough hydrogen. But remember, alkenes and the circular cycles have the same general formula. What is the meaning of that one? If I put these 3 carbon atom molecule as a cycle, 3 as a cycle means it's a triangle, no? Okay, carbon should have to have 4 bonds. So I'm just making a cyclopropane. So let's see that one. Carbon should have 4 bonds. No, this one has 2 bonds, 2 more. 2 bonds is already there. You put 2 more. 2 bonds are already there. This is 2 more. Now we have C3H6. This is also C3H6. And this is also C3H6. Remember, alkenes and cycloalkenes both have the same general formula. So if they say that draw an isomer of alkene without double bonds, you have to go for cycloalkane. This is our answer. Cyclopropane is our answer. Right. Now we have come to the last question of this paper. This question is about aluminium sulfate. Aluminium reacts with sulfuric acid to form aluminium sulfate. This is the equation for the reaction. What is the total number of elements in the formula of aluminium sulfate? Okay. In aluminium sulfate, Al2SO4 thrice. I can see aluminium there, 1 element. I can see sulfur there, 2nd element. I can see oxygen there, third element. So we have 3 elements in this formula. So it's a simple question. Answer is 3. A student use this method to prepare some aluminium sulfate crystals. Alright, he's going to make aluminium sulfate crystals from this reaction. Add powdered aluminium to a beaker of dilute sulfuric acid and stir. Okay, so what they do is they take aluminium powder. Why do we add powder? Why can't you add chunk of metal? Because powder has tiny particles. No? When you are tiny, the surface area is high. How it increases surface area. Now let's assume if you are a cube, only these surface means only these areas will contact with surface in outside. But when you break it into tiny parts, what will happen? You have greater surface area because each tiny part has its own surface. So add powdered aluminium to beaker in a and of dilute sulfuric acid and stir. So you add aluminium powder into a beaker which has sulfuric acid H2SO4. You have to stir it. Keep the stirring and add in powdered aluminium until it is in excess. How do you know that aluminium powder is in excess? How do you know that when you add sugar to cup of tea, when the sugar is in excess, there will be one point you will see that at the bottom this powder will settle. You will see aluminium powder settle at the bottom. That means you have excess aluminium powder. Same way, when you make a cup of tea, if you keep on adding sugar, one point you will see that sugar is depositing at the bottom. That means sugar is in excess. So same way we can find it. Filter the reaction mixture. Obviously, when I filter it, I want to remove the aluminium away. So I'm going to filter it. Aluminium will go out because aluminium is here. Now I've removed the aluminium powder. That's the remaining aluminium powder, right? Heat the filter to evaporate some water to produce a saturated solution. I'll just draw it here. So you just heat the solution. When you heat the solution, what will happen? Most of the water will evaporate. Because when you keep on evaporating a lot of water, what will happen? It's so hard because water evaporation takes time. When you heat it, some of the water will evaporate. Now you get saturated solution. That means you have a lot of crystals here. Allow the saturated solution to cool so the crystals are formed. When you let them cool, you get the crystals here. This is for the steps. Step 1, step 2, step 3. This is step 4. This is step 5. Step 6 is again filter to get the aluminium sulfate crystals, right? So here you get the crystals. Step 6. During the step 3, the reaction mixed is filtered. Identify the substance that remain in the filter paper and the substance the beaker after this filtration. Alright. So we know that in this step 3, that means here, right? Why we filter it? To remove the excess aluminium powder. So who will remain in the filter paper? Excess aluminium powder. So whatever the aluminium powder which is in excess will remain in there. So aluminium powder. What will be in the beaker? In the beaker we know that this is the reaction. What is in this reaction? When aluminium, we know we had excess aluminium. So aluminium completely react with sulfuric, you get aluminium sulfate. Now we have aluminium sulfate solution there. So what we have here is aluminium sulfate if it only aluminium sulfate, no, the reaction gives you two products, aluminium sulfate solution and hydrogen gas. Hydrogen gas will leave the system. So these are aqueous solutions. So what is the meaning of aluminium sulfate solution? Aluminium sulfate solution means aluminium sulfate dissolves in water. So that means it has water also. If it is only aluminium sulfate, you can straight away get the crystals. That's why we evaporate this water. Water is the one we evaporate here by heating. So therefore aluminium sulfate and water both are remaining there. So we have the answer for part number 1, right? State why aluminium is added until it is in excess. why we add aluminium, it is in excess. I want to make sure that all the sulfuric will get reacted. Why is that? If I have sulfuric acid remaining in an acidic solution, it's very hard to get the crystals. So these are the aluminium sulfate crystals. No, aluminium sulfate crystals. It's hard to get aluminium sulfate crystals because the reason is in the acidic solution you won't get crystals produced. So therefore aluminium sulfate crystals are difficult to gain when you have acidic solution. So I want to make sure that no sulfuric acid will remain in the solution. How I'm going to make sure that no sulfuric acid remain in the solution? I will make sure that all the sulfuric will get reacted. That's why I add aluminium powder in excess. Now we have the answer. State why the aluminium is added until it is in excess to ensure all the sulfuric acid H2SO4 acid reacts. Right. Explain why powdered aluminium is used. We just discussed to increase the surface area. Why? When you have increased the surface area, there will be rate of the reaction will be so fast. You can add a chunk of aluminium, but you have to wait for years until it reacts. So therefore, by aluminium powder, we can say that aluminium powder has greater surface area. When you have greater surface area, what will happen? It will increase the rate of or the speed of reaction. Alright, so therefore what will happen? We can perform the reaction very faster. We can get the crystals faster. The student adds 3.2 grams of aluminium to 0.120 moles of dilute sulfuric acid. Show that the sulfuric acid is not in excess. Okay. So the reaction is aluminium react with 3H2SO4. 2 aluminium react with 3H2SO4. Reaction says that when you have 2 aluminium, it reacts with 3H2SO4. Right. Now let's see, when you add 3.2 grams of aluminium, how many moles of sulfuric acid is required? Let's see. So mass of aluminium added, mass is given 3.2 grams. That's the mass of aluminium added. So that means how many? That means how many moles of aluminium added? So how to find moles? There's the equation to find moles. Moles equals number of moles equals mass divided by molar mass. How to find the mass? 3.2 grams is the mass. Molar mass of aluminium, if we check it in the period table, it is 27. So when I divide this one, I'll get the answer as 0.119 moles. Now the next question. If I add 0.119 moles, how many moles of sulfuric you need to react? Right, that's the question. So therefore we are going to find moles of sulfuric H2SO4. Moles of H2SO4 need to react with aluminium. How do you find it? This is how we do it, right? You take the number of moles of aluminium, which is 0.119 mole. Then you divide by molar ratio of that aluminium. So you divide it by 2. Then you multiply it by molar ratio of sulfuric acid. That way you will get the number of moles of sulfuric need to react with this aluminium. Let's do that calculation. Right. So therefore we know that their reacting ratio is 2:3. Therefore number of moles of sulfuric required, H2SO4 required, equals 0.119 divided by number of molar ratio of aluminium is 2 multiplied by molar ratio of sulfuric is 3. Our answer is 0.179 moles. We need 0.179 moles. Do we have 0.179 moles? No. Then we can say that, but we only have 0.120 moles. Therefore, sulfuric H2SO4 is not enough. It's less, not in excess, right? So therefore, that's our answer. Right. Now let's go for next part. The student calculate the percentage yield of aluminium sulfate obtained from 0.12 moles of sulfuric acid is 113%. Calculate the mass in grams of aluminium sulfate produced if the yield is 113%. Okay, now we have a problem. Let's go for the equation. 2 aluminium react with 3 H2SO4. Okay. So the reaction here is 2 aluminium reacts with 3 H2SO4 gives you Al2 SO4 thrice plus 3 hydrogen. Okay. The student calculate percentage of aluminium sulfate obtained from 0.12 moles sulfuric acid is alright. So moles. So let's take initial moles. We have used 0.12 moles. Okay. And we know that when they react, their reacting ratio is 3:2 because I'm just only focusing on aluminium sulfate product. Alright, so I know the amount of aluminium sulfate now we are supposed to get. Therefore, aluminium sulfate produced. That's what we are expected, right? So we call it expected aluminium sulfate produced. Expected aluminium sulfate produced is 3:2. No? How you know how to find it? You take 0.12 divided by mole ratio of sulfuric, the one you are considering, multiplied by mole ratio what you want to find. So it's 0. So it should be 0. Sorry, it's not 3:2. Sorry, it's my mistake. It is 3:1. Okay, so our answer is 3:1. So here you don't need to do anything. It's so easy. Here 3:1. So I'll just erase this part also. Okay. So it's here value is 3:1. You can see it's 1 here, right? So what you have to do is you have the mole ratio of sulfuric, which is 3, you divide by 3 and multiplied by mole ratios of aluminium sulfate, which is 1. So my answer here is 0.04 moles. That's the expected moles of aluminium sulfate. Therefore, can you find the expected mass? Expected mass of aluminium sulfate, Al2 SO4 thrice. We know that if number of moles equals mass divided by molar mass. Therefore, mass equals number of moles times molar mass. Molar mass of aluminium sulfate, we have to do the calculation. So aluminium sulfate molar mass, Al2 SO4 thrice. Aluminium is 27, so there are 2 of them. 27 times 2 plus sulfur, there are 3 of them. Sulfur is 32, there are 3 of them. 32 times 3. Oxygen is 16, there are 4 of them. and 4 times 12. 4 times 12 is 12. So 4 times 3. 4 times 3 is 12. So it's simply 16 times 12. So when you do this calculation, you will find the mass of aluminium sulfate. Number of moles of aluminium sulfate is 0.04. Molar weight of aluminium sulfate is 342. That means I am expecting 13.68 grams of aluminium to produce. This is the expected mass. Expected. How to find this percentage yield? So this is the equation for percentage, right? Percentage yield equals, what you do is you take the actual mass. Actually, you get actual mass. What you get really. You divide by theoretically expected. So, theoretical mass. Theoretically expected from the calculation how much you get expected into 100. So they say that percentage yield is 113%. Actual mass, that's the question they're asking. Calculate the mass in grams. What you really get? We get actual mass and we don't know how much. But can you see it's more than, okay, 130 actual mass. Theoretically expected we know is 13.68 into 100. Therefore actual mass will be, so therefore actual mass equals 113 times 13.68 divided by 100, and when you do it your mass will be 15.46 grams. That's the answer. So actual mass is 15.46. Now we have a problem. What is the problem? According to the calculation, we are supposed to get 13.68 grams, but we got 15 grams. It's like you expect to have 13 grams, but you get 15 grams, something like this. Let's take, you are going to make a bread. To make the bread, you put 1 kilograms of flour, or like we say 1000 grams of flour. Inside the oven, nothing is added from either some dirt or something added. Otherwise, if you get the bread, the weight of the bread should be 1000 grams. But suddenly you get the weight of the bread as 1200 grams. Now we have question mark. How we get more mass? This is a common thing that we can see when you're making crystals. Why is that? Because we get these crystals in the medium of water. In this medium there's water. Plenty of water is there. So what you do is we filter it. When you filter it, but still moisture will be there. After filter, what you do is you have to dry these crystals until what? All the moisture is gone. But if you don't dry it properly, what will happen? Moisture will remain there. We did the calculation to find the actual mass, the mass of aluminium sulfate we are supposed to get. We didn't never talk about the water. So if your crystals are not dry enough, what will happen? Some of these water will remain in the crystals. Crystals are not dry enough. So when you measure the mass, you will get situation like this. The mass is more than you expected. So now asking, suggest a mistake the student made when carrying out the method that caused the percentage yield to be greater than 100%. The reason is crystals are not dried properly and some amount of water is remaining. That's why your mass is more than what you expect. Okay, now we finish the first paper in 2025 November exam series. Okay, if you have any doubts, you can just leave a comment and then we'll do the next paper number 2 in 2025 November, and I'll come with the new video with that. Thank you.